Welcome guys to my YouTube channel. Remember we had a video lesson last week where I told you how to determine your endpoint without having to do any experiment. Remember in this video lesson we are going to be talking about 2024 likely Waec chemistry practical questions, and you should remember that this particular titration is redox titration. It's not like the other titration that requires indicator. In this titration, no indicator is required. Now, today we have predicted questions or likely questions that you have to see in your Waec Practical Chemistry Exam 2024. So we are going to begin with this particular question and we are going to dissolve this question. Now, let's quickly look at this question quietly. Now, A is a solution of KMNO4, that's potassium tetraoxomanganate word 4. A is a solution of KMNO4, okay? Then you have B is a solution of FeSO4. Remember in my last video lesson, I told you that this guy is the oxidizing agent, and this guy is the reducing agent. So in this particular titration, you are titrating oxidizing agent against reducing agent. This is a reaction between OA, oxidizing agent, and reducing agent. That is why it is called redox titration. Okay? So, while A is your KMNO4, B is your FeSO4. Now, they now gave us the concentration of B by telling us that FeSO4 containing what? 1.484 grams of the compound in 250 cm3 of the solution. Okay? Now, this is your A and B. Now, look at the steps. The step says that put A into the burette. Remember that your acid is to be in the burette. This time you have oxidizing agent in the burette. Okay? Pipette 20 or 25 cm3 of B, which is this, into the conical flask. Add your words, 20 cm of H2SO4. The purpose of adding H2SO4 to this guy is to precipitate interfering gases that could interfere with the result. So when you add H2SO4 to the KMNO4, if this KMNO4 has absorbed any gases, it will be precipitated out. So that's why we add H2SO4. It's not part of the word reaction. It has nothing to do with the reaction. You are not reacting any of them with H2SO4. It's only acting as to do what? To precipitate the gases that this compound might have absorbed in the course of preparing the specimen. Okay? Now, and titrate with A. Repeat the procedure to obtain concordant word, tighter values, tabulate your readings, and calculate the average volume of A used. Equation for the reaction. This is the equation. Oxidizing agent, reducing agent. This is the acid that is added to this, okay? Then, or the acid that is required to balance the equation. Then this is your product. Now watch this. This reaction does not involve the production of salt and water. No. Okay? It's just a reaction between a reducing agent and an oxidizing agent. Now these are the relative atomic masses for the atom. From the equation and result obtained, calculate concentration of B in mole per dm cube, concentration of A in mole per dm cube, number of ions of Fe plus in the volume of the word pipette. This question is quite very easy. When you come across this question in your 2024 exam, how do you go about it? Now, you are supposed to go about it doing this experiment. But from my previous video lesson, I told you how you can get your titer value without having to do your experiment. So our titer value that was gotten from the specimen given was meant for this particular question. So the titer value is 18.0. That is the volume of the acid. So how do I manipulate my value so that I have a table of values? Having known your endpoint as well, 18.0, you can manipulate your values this way. Just follow me carefully. You begin by doing burette readings. You begin by doing direct readings. Okay? Remember in direct readings, you have number one. You have number one, final readings. You have initial reading. And you have volume of A used. This is what you have. These are you can manipulate. If you already know your endpoints, you can manipulate your table. Okay? I did that last video lecture. So what you have here is your rough. Remember your rough must be in what? CMQ. After that, you have your first title. Your first title is also a CMQ. Your second title, then your third title in CMQ. CMQ. So what do we do? I've told you before, to avoid errors, make sure your initial values are 0. So initial readings will be 0.00, 0.00, 0.00, 0.00. So avoid errors. And if you already have your endpoints that you were given, okay, like from this experiment, the endpoint is 18.0. So we can begin that our rough can be 19.0. So that we go back to 18.00, 18.10, 18.20. Remember that the errors could be plus or minus 0.2. So let's subtract 19.0 minus 0 give us 19.0, 18.00, 18.10, 18.20. This is our what? Table of values. Okay? Now, if we have this as our table of values, we can calculate for the average volume of the acid. What is the average volume of A used? The average volume of A used is to add this one to this one to this one. Remember, you don't need to add your rough because your rough is so far from the actual readings. You can put any value as your rough here. Like I told you, because you're already aware that it's 18, so you can put your rough as 19. Okay? So the average volume of A is what? You add this 18.00 plus 18.10 plus 18.20. Add everything together and divide by 3. Why are you dividing by 3? Because you are taking 3 particular words values. Okay? Please do that for me quickly. Okay, if you add all of this and you divide by 3, you have 18.10 CMQ. So this is the average value of the word A used. So the purpose of this experiment is to get this table. So if you know your endpoint, you can manipulate your table this way. And when you are done with your table, then you calculate for the average volume of word A used. After doing this, remember I told you, you can now go on to do your calculations from what is given to us. Now, let's quickly solve this question one after the other. Take a look at this question again. The question says that we calculate the concentration of B in mole per dm3. Concentration of B in mole per dm3. Go back to what was given. Remember they told us that B is a solution of FeSO4. Are you seeing it now? They gave us the mass. The mass of B is 1.4 gram that is contained in 250 cm cube. That means if you have 250 cm cube of B, it contains 1.4 gram. So remember that if you are looking for concentration in mole per dm cube, like they asked us to calculate here, concentration of B in mole per dm cube. If you are looking for concentration of B in mole per dm cube, you need to know the concentration of the mass in gram per dm cube. And the concentration of the mass in gram per dm cube is the mass that has been dissolved in 1000. So what we have here is this. Watch me carefully, please. Okay? Now, because after this, I'm going to give you an assignment on this also that you will have to solve. Now, this is 1.48 in 250. So what do we do? Remember, we are told to calculate for concentration of B in mole per dm cube. So what do we do? Look at it carefully. Very easy. The mass they gave us is 1.4 gram of the compound in 250. Yes, this is what they gave us. So we can say that 1.4 grams in what? Or you can say is contained in what? 250 cm3. No be me talking. This was what was given in the question. 1.4. So let us now know the mass that is in 1000. Because for you to calculate for concentration in mole per dm3, you must know the mass in 1000. So let's know the mass in 1000. So we can say that S gram is contained in 1000 cm3. Remember that concentration is the amount of solute in grams or in moles that is contained in 1000 cm3 or 1 dmg of the solvent. So if they gave us this, we need to know the one in 1000. So what do? You do x times 250. That will give us 250 words x equals to 1.4 times 1000. We give us 1.4 bracket 1000. So what do? Divide both sides by 250. Divide here by 250. This one cancel this x will give us what? Please do that carefully. Okay, so we have 5.6 gram per dm3. Yes, this is our what? Mass concentration. This is the mass of B that is in 1000. Now we can go as far as to calculate for concentration in mole per dm3. How do we calculate for concentration in mole per dm3? Please take your book and your pen and jot this down. Now, concentration in mole per dm3 is equals to concentration in gram per dm3 over molar mass. Wow, that's interesting. So after you don't calculate your concentration in gram per dm3, this is the mass in 1000. Don't forget that dm3 is 1000. So the mass in 1000 is 5.6 gram per dm3. So when you have done that, you can now calculate your concentration in mole per dm3. So how do you do that? It is mass concentration over molar mass. That is to say, we need the molar mass of this compound. So let's print a portion of this board to do that. So what do we do now? Let's calculate for the mass of the B. B is FeSO4. Let's calculate the mass. Oh yeah, molar mass of FeXO4. The mass of iron is given here as what? 56 plus the mass of sulfur is 32. The mass of oxygen is 16 times 4. So we have 56 plus 32 plus 64. Do that for me quickly. Add this together. 152, right? So we have 152 gram per mole. This is the molar mass of the compound. So what do we do now? We are going to calculate for what? The concentration in mole per dm3 by dividing the mass concentration over the what? Molar mass. So let's do that quickly. Concentration in mole per dm3 will give us what? Mass concentration, which is what? 5.6 over molar mass 152. Now do that quickly. 0.03684. Is that correct? Good. So don't forget that most times our concentration is in 3 decimal places. So 1, 2, 3. We can have 0.037 mole per dm3. Meanwhile, when doing your calculation, you can use this, but this is our concentration. So therefore, we can say that concentration of B in mole per dm3, the concentration of B in mole per dm3 is equals to 0.037 mole per dm3. Take note of that. We have gotten concentration of what? Of B. Now the next question says what? He said concentration of A in mole per dm3. Okay? Now let's clean this portion of the board to calculate for concentration of A in mole per dm3. Let's take question number 2. Question number 2 says concentration of A in mole per dm3. Now let's get concentration of A. Remember that your A is KMnO4. And if you go back to the question that was given, the mass of A was not given. So they not give us any data about A. The only thing we know about A is that from the table of values that we drew, we knew that our volume of A, the average volume, is 18.10 cm3. And now we are looking for the concentration of A. Did we know the volume of B? Remember that the volume of B is the volume of the pipette, which is always 25.0 cm3. Check my previous video for that. Now, what is the concentration of B? We have that it is what? Or we take this 0.03684 mole per dm cube. Now, that's so interesting. Remember that from the equation given, this is A and this is B. So what is the number of moles? What's the number of moles of this A? What number of moles of this A? The number of moles of A is what? How many moles do we have here? Is 1. The number of moles of B is equals to what? 5. That's like saying that A is 2, B is 10. So whether you say 1, 5 or 2, 10 is the same thing. So better still, from there you have 1, 5. Now if we have all of this, we have to go back to our Calvin formula that says CAVA all over CBVB equals to NA over NB. This how we calculate for word CA. So let's do this quickly. CA is what we are looking for. VA is 18.10. All over CB 0.03684 times VB. Our VB is 25.0 equals to NA, which is 1 over 5. Wow. Now, let's quickly do this. This times this 18.1 CA equals to, multiply by 5 times 5 equals to, 0.03684 times 25 times 1. So what do we have here? We have to multiply 18.1 by 5. Let's do that quickly. 18.1 times 5. That will give us 90.5. So we have 90.5 CA equals to, let's do the order, 0.03684. 0.03684 times 25. That will give us 0.921. So we have 0.921. Therefore, CA will give us 0.921 over 90.5. So CA will give us what? 0.921 divided by 90.5. You have 0.01. 0.01. 10 mole per dm. So if you watch very well, you will see that our predictions was very correct. Remember the endpoint I gave you? I gave you an endpoint of 18.0. And from the video I did last week, I showed you how to get your endpoint. And then you discover that the concentration that we have gotten for the A and B coincides with the previous video. That is to show that your experiment is what? Accurate. Okay? That is to show that you have followed the right procedure in preparing the word specimen for the student. So if I have my CA as this and I have my CB as this, wow, that's interesting that my results that I got, the endpoint is very, very accurate. That's why I discovered that my CA and my CB still falls within the parameters of what the specimen was describing. That's quite very interesting. So we are going to take this last question on this. By the time I'm done with this, I am going to do what? I'm going to give you a question to solve. Okay? When you solve this question, you please send me your answer in the comment section. Now let's take question number 3. They said we should do what? Calculate the number of ions of Fe2+ in the volume of the pipette. Calculate the number of ions in Fe2 plus in the volume of the pipette. What do we need to do? Very easy. All we have to do is simple. Let's first of all calculate the number of moles. Remember, number of ions is the same as number of particles. And number of particles mean number of moles times Avogadro's constant. So, if you are looking for number of ions or number of atoms or number of molecules, you must know your number of moles. So, we go first calculate number of moles first. That's what we need to do. Remember, the number of moles in the volume of the pipette. Remember, the volume of the pipette is 25 cm3. 25.0 cm3. Now, remember that in the concentration of B, the concentration of B says 0.03684 mole per dm3. What does that mean? It means the number of moles in 1000 cm3. Because per dm3 means 1000. So we can say that we have 0.03684 moles in 1000 cm3. That's what we have. Because when you see this per dm3 mean 1000. So what do we do? Remember, the volume of the pipette is 25 cm3. So we can say that we have S mole in what? 25 cm3. Because we are looking for the number of moles in the volume of the pipette. So what do? We cross multiply. So that we have X equals to 25 times 0. You know you have to use to multiply this, then this to multiply this. So you have 25 times 0.03684 divided by what? 1000. This will give us the number of moles of Fe2 plus in the volume of the pipette. So what do? Let's do this quickly. 25 times 0.03684 divided by 1000. As you do it, let's do it again. 25 times 0.03684. So we have 0.921 divided by 1000. That will give us, divide by 1000. That will give us 9.21 times 10 raised to the power minus 4 moles. That's the number of moles that we have. Now, if we have this moles, how do we calculate for number of ions? Remember, number of ions is number of moles times Avogadro's constant. Take note of that. So, wetin be the number of moles? See am here. Did they give us the Avogadro constant? Yes. What is the Avogadro's constant? Let's do that quickly to get the number of ions. So, we have number of moles 9.21 times 10 raised to the power minus 4. Avogadro constant is 6.02 times 10 raised to the power 23. So, let's do that. We are going to multiply by 6.02 exponential 23. We have 5.54 times 10 raised to the power 20 ions. So, the number of ions in the volume of the pipette is this. This is the number of ions, okay? Now, I'm going to give you an assignment. Please make sure you do this assignment to prove that you actually understand this. And if you have any complaints, please send it to me in the comment section. Do the assignment and send it to me in the comment section. Okay, now, here is prediction 2. You are going to take this as your assignment. Remember that your endpoint remains the same. What is your endpoint? 18.0. So you have to manipulate a table around 18.0 like the way I taught you. You calculate the average volume of A. When you are done, then solve this question. Okay? This is prediction 2. Please, when you are done solving, send your answer to me in the comment section. For any complaints or questions, please, you can send it to me in the comment section or you can chat me. My number is on the YouTube. Thank you very much. I'll see you again in my next video lesson.